You ever just look at a huge river and think about all the raw power that's just flowing right by? Well, today we're going to break down exactly how we tap into that. How the simple force of moving water, seriously, can light up an entire city. So yeah, let's dive right in. I mean, it sounds almost like magic, right? How does a river end up powering the lights in your house or even the screen you're looking at right now? That is the big question, and that's exactly what we're here to answer. Okay, so the short answer? Hydropower. But what is that really? It's all about this super clever process of changing energy from one form to another. We're taking the energy that water has when it's moving. Scientists have a name for that. It's called kinetic energy. And we're turning it into the electricity we all use every single day. And to really get it, let's actually follow that energy, step by step, on its incredible journey. Think of it like a story, you know? It starts with calm, still water and ends up as a spark of electricity in your home. So here's the whole roadmap for that journey. You can see it's basically a 6-step process. We've got water storage, flow, turning a turbine, generating electricity, sending it out, and then the water goes back to the river. We're going to walk through every single one, starting right at the top with number 1, water storage. All right, so it all starts with a dam, a big one. By holding back this huge lake of water, this reservoir, the dam is basically building up a massive bank of stored energy. It's called potential energy. And the key is height. The higher up that water is, the more potential energy it's got locked away. Okay, now here comes the first big change. The gates open, and all that stored potential energy gets unleashed. It instantly transforms into kinetic energy. That's the energy of motion we talked about, as the water just thunders down these huge pipes called penstocks. So we've gone from still and waiting to incredibly fast and powerful. And if that potential versus kinetic thing is a little fuzzy, this makes it super clear. Just think about it like this, right? If you're holding a book up in the air, that's potential energy. It's just stored up, waiting. The second you let that book go and it's falling, boom, that's kinetic energy, energy of motion. Hydropower is the exact same idea, just, on a ridiculously massive scale. So you've got all this incredibly powerful water rushing down. Now what? Well, we use it to spin a giant wheel, kind of like a massive pinwheel, called a turbine. And this is our next big energy swap. The water's kinetic energy gets turned into mechanical energy as it physically spins those turbine blades. And right here, this is the heart of the whole operation. This is where the magic really happens. That spinning turbine, it's hooked up to a generator. And inside that generator, you've got magnets and coils of wire. As the turbine spins everything, that motion gets turned into an electric current. And just like that, bam, the mechanical energy is now officially electrical energy. Okay, so from there, the last couple of steps are pretty straightforward. It's all about delivery. That electricity gets sent out over power lines to our cities and towns. And the water? The water that did all that heavy lifting, it just flows right back into the river downstream. Its job is done, and the cycle is complete.
Okay, I know that was a lot of physics, a lot of engineering terms. But don't worry, there's a way simpler way to think about all this. A really fantastic analogy that just makes the whole thing click.
It's this right here. Falling water spins a wheel, the turbine, which turns a generator to make electricity, just like how a bicycle dynamo makes light when the wheel turns. It's perfect, isn't it? If you've ever had one of those little lights on your bike that turns on when you pedal, you've seen a mini hydropower plant in action. The spinning wheel turns a little generator, the dynamo, and makes light. A dam is just a gigantic version of that exact same concept.
So, okay, that's how it works. But the bigger question might be, why does this matter? Why do we go to all this trouble? What are the actual benefits?
Well, the advantages are actually pretty huge. First off, it's renewable. It runs on the water cycle, which isn't going anywhere. It's also super clean, no air pollution when it's running. On top of that, it's incredibly reliable and efficient. And some plants can even store energy, which is a massive bonus. So if there's one big takeaway, it's this. Hydropower doesn't use up the water. It just borrows its energy for a little while as it passes by. It's a really elegant way to work with the natural flow of a river to generate clean power. And that kind of leaves you wondering, doesn't it? We figured out how to harness the power of falling water to light up our entire world. So, if we've mastered that, what's next? What other massive forces of nature are we just on the edge of figuring out?